Hello, hi everyone. Today we are with another problem from the Leetcode, and the problem is 347 top k frequent elements. The difficulty level for this problem is given as medium. So let's understand the problem and then we'll begin with the coding. The problem statement here is given an integer array nums and an integer k. Return the key most frequent elements. You may return the answer in any order. Okay. And we also have an example here. So let's try to understand the example. So we have 1, 1, 1, 2, 2, and 3 in the example. So the count of 1 is 3. So occurrences. The frequency of 1 is 1. Or say the count of 2 is 2 and the count of 3 is 3, right? And we also have a k value which is given as 2. So return the key most frequent elements, which means if the value of k is 2, we have to return the two most frequent elements. So if we like, since it is already sorted in the uh, highest frequency to the lowest frequency, yeah, I have made a mistake here. Highest frequency to the lowest frequency, we'll have these two value as the result, which means 1 and 2 should be the output. And here we have an output as 1 and 2. Similarly, when there is a single element in the list and the value of k equals to 1, then a single value is returned. We also have an additional information here that in the constraint section, that it is guaranteed that the answer is unique. So there is a 100% chances that the answer is unique and we will not have an ambiguous answer for which we'll have to define some other conditions. Okay, so it's pretty straightforward. We also have a follow-up question here, but we'll catch up with this later. First, we'll try to solve it using the brute force approach and see how it goes. So the first thing that comes to my mind when I see this problem statement is I have to calculate the frequency of numbers in nums, right? Then I have to sort in uh, highest to lowest count frequency, right? And then third is return k top elements, right? So this is the basic thing we have to work upon to solve this problem. Then let's try to do it one at a time. To calculate the frequency of number in numbers, what we can do is we can take a user dictionary, and that dictionary can be called as frequency. So for n in nums, frequency of number should be frequency dot get number. If it's not there, initialize it with 0 and then add 1. This way what we'll have is we'll have all the frequency for the respective elements of the number. So 1 is 3, 2 has an occurrence of twice, and 3 has an occurrence of once, right? Then the second step is to sort in highest to lowest frequency. And for this particular example, it's already sorted, but this could not be the case always. So what we'll do is we will sort it. And to sort the dictionary, what we can use is the sorted method. And for this, we have the first argument as the dictionary itself, second argument as key, And to sort the dictionary based on the values, what we can do is we can use this as a key, and we also want to uh, do the sorting in the highest to lowest. So we'll reverse the sorting thing, and then at the end, the third step is to return the key elements. So we can slice this and then return the key elements. So yeah, we have an answer here already. And let me try the test cases that is given, and that is also accepted. So if I submit this, let's see what it happens when I submit it. Yep, it is accepted and all the test cases have been passed. But we have a follow-up question here, and the follow-up question is your algorithm's time complexity must be better than order of n log n, where n is the array size, right? And since we are using a sorted function here, so sorting in Python has a time complexity of n log n. And considering that there could be a case where all the elements are different, unique, and there is no repetition, that means all the elements have a frequency of 1, the dictionary will have n number of key value pair, and then sorting would again take n log n. So this is the time complexity currently is big O of n log n, right? And we have to improve it. Can we do this better? So for this, what we can do is we need to remove this sorting and then find a technique so that we can retrieve the highest order, highest frequency element first, and then the lowest frequency element, append it to the some kind of list, and then maybe return it, right? So let's first remove these two things and understand how it can be done. So let's take an example here. 1, 2, 2, and 3. So what we can do is we can create a list of list where initially all the lists are empty, and these indexes represent the frequency of that particular element. For example, 0 index will have nothing because nothing has a, like if the array is empty, it will be 0 index element. Otherwise, 1 index element will have uh, the elements which have the frequency of 1. For example, in this particular case, we have 3 with have frequency of 1, so it should be placed in the index 1 list. Then we have 2 2, so it should be placed in the second index, and 3 1, so it should be placed in the third index. And what should be the size of this list that I am creating is apparently the number of elements in the list, the number of items in the nums list, right? Because there could be a case where these all are a single element, like 1 1 1 1 1, everything is 1. So there will be 6 1. So we want at least the value, the list to have a empty list with a maximum frequency of 6. So 6 index should be present. That means the number of elements in nums plus 1. So 1, 2, 3, 4, 5, 6, 7. So if there was a case when it was all 1, then this 1 would have been placed here instead of at the third index. So that is one of the possible cases, right? And to create this list, I'll use another variable called this count, and we have for I in range length of nums plus 1, right? This way we will have all the empty list. up to n elements, right? These are all empty. So the next thing is we want to put the elements in the respective index as per their frequency count, as per their frequency. So what we can do is we can say that n is the element and f is the frequency in frequency dot items dictionary, frequency dictionary. Then we want count of that frequency equal to n, right? Or not equal to, but append, because there could be also the case when there are 2 1 and 2 2. So we would want both of them to be a part of the second index list, right? So we'll use the append function here. Then we can check if our count has the correct value now. Let's see. Yes, it has. 3 is positioned at index 1, 2 is positioned at index 2, and 1 is at position at index 3, because 1 has a frequency of 3. Now, like instead of using the sorting, what we have done here is we have positioned the numbers as per their frequency. The next thing that we are supposed to do is find it in the reverse order, so that the highest frequency, let's say if this particular list had some value, then this would have the highest frequency, and then we would append it to the output. If not, then we will move backwards to the position 0 till 0, or like we do not, we should not even consider 0, because there will not be such cases. So we'll have to use another for loop, and that for loop would be from for I in range length of frequency, which is 6, right, minus 1. So length of frequency is, sorry, length of count is 7. 7 minus 1 is 6. So we want to see what is at index 6, right? And we want to iterate till the, like before the 0th index and in a backward manner. So we can do this in Python, right? And then we want to see that if there is a number in that particular position, then we want the result to have that value. So result dot append n, right? And also after appending the result, we want to check if the length of result equals to k, because that is the maximum limit our output can hold, right? And at that point, what we can do is we can return the result, and since it is guaranteed that there will be a unique answer, this is the case. Okay, and when I try to run this, let's see how it goes. Yep, it works, and it passes for all the test cases, including one with the single element, right? And what is the time complexity here is, here it could be the at most big of n. Again, we are using an additional space here to avoid the sorting, which has a higher time complexity. So there is a trade-off between time complexity and space complexity now. And here as well, the time complexity is, since we are iterating over all the elements in the dictionary, it's also big of n. And then we are using this for loop, and within the for loop we have another for. But if you carefully check this, what you can find is that at most the number of elements that is being seen or like utilized in this for loop is all the elements that is present in the original list nums, right? So in the for example, in the at position 6 there is nothing, so probably this for loop will not execute at all. Then at position 5 there is nothing, at position 4 there is nothing, at position 1 there is a single element, so a single element will be processed, right? And then at position second 2 there will be a single element, then again a single element will be processed, and this way we are just utilizing at most the unique elements, the distinct elements that is present in the original list, and the distinct elements that is present in the original list is simply n. So now we have reduced from the time complexity order of n log n to order of n, right? And let's try to submit this. And yes, it works. Although the time complexity here is like, I don't know how it's calculated. Again, for the Leetcode, the calculation are quite different. It's based on the distribution and number of summation that is done by the candidates. But we have significantly reduced this time complexity. Also depends on the test cases. Okay. All right. So that's it. If you have any suggestion, please leave it in the comment box. And if you know a better solution to it, please let me know. Thank you. अब चाहिँ नेपालीमा हेरौँ है त. सो आजको क्वेसन रहेको छ टप की फ्रिक्वेन्ट एलिमेन्ट्स भनेर, अनि यसको चाहिँ डिफिकल्टी लेभल मिडियम हो. सो यो क्वेसनमा चाहिँ के छ भनेपछि एउटा इन्टिजर एरे छ नम्स र एउटा इन्टिजर के भनेर छ. सो इन्टिजर एरे नम्सबाट चाहिँ हामीले के मोस्ट फ्रिक्वेन्ट एलिमेन्ट्स चाहिँ रिटर्न गराउनु पर्ने अरे. अनि रिटर्न गराउँदाखेरि जुनसुकै अर्डरमा भयो नि हुन्छ भन्नाले आउटपुटको चाहिँ अर्डर म्याटर गर्दैन. 2 1 भयो नि हुन्थ्यो, 1 2 भयो नि हुन्छ. सो यहाँ एउटा इक्जाम्पल हेर्दाखेरि के छ भनेपछि 111 2 2 3 होइन, अनि के को भ्याल्यु 2 छ भनेपछि हाइएस्ट फ्रिक्वेन्सी चाहिँ यसमा के को छ, कुन एलिमेन्टको छ, 1 को छ. 1 को फ्रिक्वेन्सी कति छ, 3, राइट. त्यसपछि चाहिँ सेकेन्ड हाइएस्ट फ्रिक्वेन्सी कसको छ, 2 को छ. दुईटा अकरेन्सेसहरू छ. सो हामीलाई कतिवटा मोस्ट फ्रिक्वेन्ट एलिमेन्ट चाहिएछ, दुईटा. सो हाम्रो चाहिँ 1 र 2 चाहिँ आन्सर हुने भयो, राइट. सो यसलाई चाहिँ ब्रुट फोर्स अप्रोच अथवा इन्ट्युटिभ हाम्रो सोल्युसन सोच्दाखेरि चाहिँ हाम्रो के हुन्छ भनेपछि पहिला त हामी फ्रिक्वेन्सी चाहिँ क्यालकुलेट गर्छौँ. त्यसपछि चाहिँ फ्रिक्वेन्सी क्यालकुलेट गरेर डिक्सनरीमा स्टोर गऱ्यौँ भनेपछि त्यो डिक्सनरीलाई चाहिँ हामी सर्ट गर्छौँ र सर्ट गर्ने बेलामा चाहिँ हाइएस्टदेखि लोएस्ट फ्रिक्वेन्सीको अर्डरमा गर्छौँ. सो द्याट हाइएस्ट फ्रिक्वेन्सीको भ्याल्यु चाहिँ हामी पहिला झिक्न सक्छौँ. अनि त्यो हाइएस्ट फ्रिक्वेन्सी टु लोएस्ट फ्रिक्वेन्सी गर्दाखेरि चाहिँ हाम्रो के टप एलिमेन्ट छ भनेपछि के एउटा एलिमेन्ट चाहिँ त्यो डिक्सनरीबाट झिक्यो भने चाहिँ वी आर गुड टु गो, राइट. तर यो समिसन लाइक यो अप्रोचले पनि काम गर्छ. तर यहाँ चाहिँ हामीसँग एउटा फलोअप क्वेसन छ एज अ च्यालेन्ज. र त्यो च्यालेन्ज के छ भनेपछि के हामीले चाहिँ यस्तो अल्गोरिदम बनाउन सक्छौँ जसको चाहिँ टाइम कम्प्लेक्सिटी एन लग एन भन्दा बेटर हुनसक्छ. अब एन लग एन भन्दा बेटर हुनसक्छ भनेर किन भनेछ भनेपछि हामीले यहाँ फर्स्ट जुन इन्ट्युटिभ ब्रुट फोर्स अप्रोच युज गऱ्यौँ त्यसमा सर्ट अपरेसन युज गर्दैछौँ. र पाइथनमा सर्टिङ चाहिँ सर्टेड यदि फङ्सन कल गरिरहेको छ भनेपछि त्यसको टाइम कम्प्लेक्सिटी अर्डर अफ एन लग एन हुन्छ है त. सो हामीले चाहिँ फ्रिक्वेन्सी क्यालकुलेट गर्न इट्स अर्डर अफ एन, अनि त्यसपछि चाहिँ टाइम कम्प्लेक्सिटी सर्टिङ चाहिँ एन लग एन, र फाइन्डिङ द टप के एलिमेन्ट चाहिँ अगेन इट्स अर्डर अफ एन. सो एन लग एन ओभरअल चाहिँ टाइम कम्प्लेक्सिटी एन लग एन हुन पुग्यो. सो हामी के गर्छौँ त यसलाई चाहिँ इन सम युजिङ सम टेक्निक वी वान्ट टु अभोइड, हामी चाहिँ अभोइड गर्छौँ सर्टिङ चाहिँ नहोस् र हाम्रो चाहिँ आन्सर जुन जुन अल्गोरिदम छ त्यसको चाहिँ टाइम कम्प्लेक्सिटी रिड्युस होस् भनेर है त. सो यसको लागि चाहिँ एउटा सिम्पल टेक्निक के छ भनेपछि सर्टिङ नयुज गरेर हामी के युज गर्छौँ, एउटा लिस्ट अफ लिस्ट युज गर्छौँ जसमा चाहिँ नम्बर अफ लिस्ट विदिन दिस लिस्ट चाहिँ कति हुनुपर्छ भनेपछि नम्बर अफ जतिवटा एलिमेन्ट हाम्रो छ नम्स लिस्टमा त्यतिवटा. किन भनेपछि मानौँ हामी यो 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 एउटा लिस्टलाई चाहिँ हामी के ट्रिट गरिरहेको छौँ भनेपछि यो पर्टिकुलर इन्डेक्सलाई चाहिँ त्यसको फ्रिक्वेन्सी ट्रिट गरिरहेको छौँ क्या. सो हामीलाई सर्टिङ गर्नु पर्दैन, हामी चाहिँ अलरेडी सर्टेड छ भनेपछि यसको इन्डेक्स 0 छ, यसको इन्डेक्स 1 छ, यसको इन्डेक्स 2 छ. सो हामीले इन्डेक्सलाई त सर्टिङ गर्नु परेन, हामीले चाहिँ त्यो पर्टिकुलर इन्डेक्समा चाहिँ कुन एलिमेन्ट जानुपर्ने हो त भनेर त्यति मात्र ख्याल राख्नुपर्छ. र त्यो चाहिँ हाम्रो फ्रिक्वेन्सीबाट थाहा हुन्छ भन्नाले फर इक्जाम्पल यहाँ 3 वटा चाहिँ 1 छ भनेपछि यसको फ्रिक्वेन्सी 3 छ। सो यो थर्ड इन्डेक्सको लिस्टमा गएर बस्छ। सो 2 को चाहिँ के छ फ्रिक्वेन्सी 2 छ। सो यो सेकेन्ड इन्डेक्समा गएर बस्छ। अनि त्यसरी गएर बस्यो भने चाहिँ हामीले के गर्नुपर्छ, यो एउटा लिस्टलाई इनिसियलाइज गऱ्यौँ एम्प्टी भनेर। त्यसपछि यो लिस्टमा चाहिँ हामीले त्यो भ्याल्युहरू चाहिँ कसरी जान्छ भनेर त्यो राख्यौँ। सो हाम्रो नम्बर छ र त्यसको फ्रिक्वेन्सी छ। सो पर्टिकुलर फ्रिक्वेन्सी भनेपछि त्यो इन्डेक्स हो र त्यो इन्डेक्समा गएर त्यो नम्बर चाहिँ बस्यो। अनि लिस्ट किन बनाइरहेछ भनेपछि एउटा केस कस्तो हुनसक्छ भनेपछि 1 1 छ, 2 2 छ अनि 3 छ। सो यसमा चाहिँ 1 को पनि फ्रिक्वेन्सी 2 छ, 2 को पनि फ्रिक्वेन्सी 2 छ। सो दुइटै चाहिँ सेकेन्ड इन्डेक्समा गएर बस्ने हो। सो 1 र 2 चाहिँ दुइटै सेकेन्ड इन्डेक्समा गएर बस्ने हो। तर यो अहिलेको इक्जाम्पलमा चाहिँ त्यस्तो छैन है। अनि त्यस्तो केसमा चाहिँ हामीले लिस्ट युज गऱ्यौँ भने चाहिँ के हुन्छ, फाइदा हुन्छ। फाइदा हुनाले आन्सर सही हुन्छ। अनि अब हाम्रो नेक्स्ट काम के छ, अब पछाडिदेखि चाहिँ हामी ट्राभर्स गर्दै जाने। अनि त्यसपछि ट्राभर्स गर्दाखेरि चाहिँ रिजल्टमा अपेन्ड गर्ने। अपेन्ड गर्ने बेलामा चाहिँ हामी चेक गर्ने रिजल्टको चाहिँ लेन्थ के जुन छ नि एटमोस्ट भनेर, एटमोस्ट फ्रिक्वेन्ट के फ्रिक्वेन्ट एलिमेन्ट्स भनेर छ भनेपछि के पुग्यो भने चाहिँ हाम्रो आन्सर सक्यो भनेर हुन्छ। सो हामी चाहिँ लेन्थ अफ काउन्ट -1बाट चाहिँ सुरु गर्छौँ। 0th इन्डेक्स चाहिँ हाम्रो स्टपिङ पोइन्ट हो, किनभने चाहिँ 0th इन्डेक्समा विल अलवेज बी एम्प्टी। कुनै पनि यस्तो भ्याल्यु आउने पनि छैन जसको फ्रिक्वेन्सी 0 छ भनेर। अनि त्यसपछि चाहिँ ब्याकवर्ड डिरेक्सनमा गइरहेछौँ, त्यही भएर चाहिँ -1 है। अनि त्यसपछि चाहिँ हामी त्यो पर्टिकुलर लिस्टमा जुन एलिमेन्टहरू छ त्यो सबै एलिमेन्ट चाहिँ हामी के गर्न गइरहेछौँ, अपेन्ड गर्दैछौँ रिजल्ट भन्नेमा है त। अनि त्यसपछि चाहिँ हामी यहाँ एउटा अझै कन्डिसन चेक गरिरहेछौँ, जुन चाहिँ हाम्रो रिजल्टको लेन्थ के बराबर भयो भने चाहिँ हामीले चाहिँ यो लुप चलाइराख्नु पर्दैन, इमिडिएटली चाहिँ रिटर्न गर्दा हुन्छ रिजल्ट। अनि यस्तो केस गर्दाखेरि चाहिँ हाम्रो टाइम कम्प्लेक्सिटी n log n बाट अर्डर अफ n मा चाहिँ झऱ्यो है त। सो द्याट्स इट। अरू केही सुझाव छ भनेपछि कमेन्टमा भन्नु होला, र भिडियो मन पर्यो भने चाहिँ एक्सप्लेनेसन मन पर्यो भने लाइक गर्नु होला। धन्यवाद। सी यू इन द नेक्स्ट भिडियो। बाई।